CNBC and TechCrunch both reported late Friday into Saturday that the U.S. government is letting Anthropic reopen access to Claude Mythos 5, but only for a selected set of companies, agencies, partners, and critical infrastructure operators. That is the new fact today. Yesterday, we were talking about model access as a blocked launch or a restricted preview. Today, the block has turned into a list of names, and that changes the texture of the story. A model can be available and still not available in the ordinary product sense. It can be out in the world for more than 100 institutions, while still being unavailable to everyone else who would normally treat a frontier model release as a public platform event.
The more than 100 number is the detail that makes this feel different from a normal enterprise rollout. Enterprise access usually means procurement, trust paperwork, and a sales motion. This sounds like a release perimeter drawn around institutional function, companies, agencies, partners, and operators who sit close to critical systems. If you're an ordinary developer reading the headline, Mythos 5 is still mostly a rumor with a product name. If you're on the list, it's an instrument you can begin integrating into serious work.
And I want to keep the access perimeter in view without replaying yesterday's GPT-5-6 segment. The fresh thing isn't that a government asked a lab to slow or limit a model. We already covered that. The fresh thing is that the model release now has an operational middle state. It isn't banned, it isn't broadly launched, and it isn't a closed internal test. It's being redeployed to selected users under a permission regime with direct government involvement, while Fable 5 remains unresolved in the reporting.
That middle state is awkward because everyone has an incentive to describe it differently. Anthropic can say the model is back in use. The government can say it didn't simply throw open access to a high-capability system. Customers on the list can say they're using the frontier system their competitors can't yet touch. People outside the list have to infer the reason for the boundary: safety, national advantage, lobbying, procurement readiness, or some mix of all four.
Andrew Curran's X post was part of the early reaction here, and the upstream agenda treats it as a direct report of the block being lifted. I'm cautious about reaction posts as evidence of policy, but as a pointer, it matched the reporting that followed. The main reporting says the Trump administration released Anthropic's Mythos for use by selected American companies and agencies. TechCrunch's version stresses the scale of the reopening. CNBC's version puts it in the context of government involvement and export control style concerns around advanced models.
It also changes what fairness means in model access. For a consumer app, fairness mostly means price, uptime, and whether an existing customer gets rug pulled. For a model that can touch critical infrastructure, fairness starts to mean process. Who decides the access criteria, whether the criteria are public enough to trust, whether the list can be appealed, and whether being close to the state becomes a product advantage. That's a different kind of trust question than the one people usually bring to a pricing page.
Right. And I don't think the answer is as simple as saying frontier labs should always launch everything to everyone at once. That sounds tidy until the model has enough capability that governments, companies, and infrastructure operators treat it as more than a software subscription. The uncomfortable part is that selective access can be responsible and politically corrosive at once. It may be the safer near-term move, and it may also train the market to expect that the best model is partly a clearance process.
The word clearance is doing something precise there. Nobody has to call it a security clearance for it to behave like one. If you need the model for planning, cyber defense, energy operations, logistics, or some other sensitive workflow, the access decision becomes part of the capability. You don't just ask whether the model can reason, you ask whether your institution is recognized as the kind of institution allowed to receive that reasoning early.
That leads to the first segment's central question. What kind of market is forming around frontier access? We have labs, governments, and major operators converging on a world where release is no longer a single public event. It can be staged by geography, sector, customer status, safety review, and political relationship. Maybe that is inevitable for the strongest systems, but once it becomes normal, the model card is no longer enough. People will also want the access card. Who got it, why they got it, who didn't, And what evidence would move someone from one side of the line to the other?
That would be a better public artifact than another vague assurance. The model card tells you about training, evals, limitations, and sometimes deployment rules. The access card would tell you how the release perimeter was drawn. It would say whether the boundary is about export risk, misuse risk, critical infrastructure dependence, national security review, compute scarcity, or simple phased rollout. Those aren't interchangeable reasons, and treating them as interchangeable is where trust starts to leak.
This story isn't anti-lab or anti-government by default. I can imagine very good reasons not to turn on a model everywhere on a Friday night, especially if the people closest to the model think it can do things that would be hard to unwind. But managed access becomes legitimate through its process, not through the prestige of the people involved. If Mythos 5 is the first version of this pattern that feels visible from the outside, the next one needs more than a list that appears through reporting after the fact.
And because this is Braid, I want to keep the strange possibility in there too. Selective deployment isn't only a restriction. If the selected operators are real infrastructure operators, it could mean the most capable model gets tested against serious operational tasks before the wider product world sees it. That might produce better evals, better monitoring, and better evidence about what the model does under pressure. We still need to know whether any of that evidence becomes public enough to learn from, or whether the public only sees the permission boundary and has to guess what happened inside it.
Techmeme's hardware items today point away from the accelerator headline and toward the manufacturing stack around it: advanced packaging, memory sourcing, foundry commitments, and the politics of where the work can happen. The lead supply chain item is about dependence on Taiwan for advanced chip packaging and U.S. efforts to reduce that exposure. Another item has Intel offering advanced node testing tools to SpaceX and Apple before they make final commitments to Intel 14A. A third has Apple seeking clearance to use memory chips from China's CXMT.
That is a useful correction to the way people talk about AI hardware. The chip is the object people can picture. Packaging, high bandwidth memory, test tools, process commitments, and export clearance are harder to picture, so they get treated like background. But if one of those parts is constrained, the accelerator headline doesn't get you the throughput you thought you bought. The bottleneck can live in a substrate, a memory stack, a trusted supplier list, or a government approval process.
The Intel detail is especially interesting because it isn't Intel announcing that Apple and SpaceX have committed. It is Intel trying to reduce the risk of commitment by letting major potential customers test advanced node tools before the final yes. That tells you something about the foundry business. A process roadmap isn't enough. Customers need confidence that the tools, yields, timelines, and support will be there when their own products depend on the node.
And for AI companies, that confidence problem compounds. If you're designing a product cycle around a future node, you don't only care whether the transistors work. You care whether the packaging partner can keep up, whether memory is available at the volumes you need, whether the export rules change your supplier set, and whether a geopolitical incident turns procurement into an executive-level problem. Procurement suddenly has plot.
Procurement has plot as fair. The Huawei item in Forbes sits on the other side of this. Huawei's chip strategy under pressure is presented as adaptation under restriction, not as a solved alternative to the global leading edge. That's important because the temptation is to narrate every workaround as proof that controls failed. Sometimes a workaround proves ingenuity. Sometimes it proves that the constraint is expensive and people route around whatever parts they can.
The Apple and CXMT item has that same texture. If Apple is seeking clearance to use memory chips from a restricted Chinese supplier, the company isn't making an ideological point. It's trying to keep a product and supply plan coherent inside a rule set that keeps changing. The policy regime reaches into a bill of materials. It decides which memory chips can sit beside which processors in which products, and that becomes part of the AI-capable device story, whether or not the product is marketed as AI hardware.
So put Mythos beside this, but lightly. In the model story, permission decides who gets to touch the capability. In the hardware story, permission and geography decide who can manufacture enough of the capability to matter. I don't want to force them into one grand theory, because they're different mechanisms, but they rhyme in one practical way. Access is becoming a stack. There is model access, chip access, memory access, packaging access, and foundry trust. A company can be blocked at any layer.
That also makes the next few years less glamorous than the launch posts suggest. The hard work isn't only making the next model smarter, it is turning scarce physical capacity into dependable service without accidentally making every supplier decision a political referendum. When people talk about sovereign AI, they often mean models and data. The supply chain items today are a reminder that sovereignty also means packaging capacity, memory policy, test tooling, and the patience to qualify a foundry process before you bet a product cycle on it.
And there is a scale question inside that. A lab can announce an impressive capability and then limit it to a small number of trusted institutions. A hardware supplier can't handwave the substrate, package, memory, and yield path if the product needs millions of devices or sustained data center deployment. The physical system doesn't care how elegant the demo was. It asks whether the process exists, whether it repeats, and whether the supply chain survives contact with law, weather, politics, and demand.
Intel courting Apple and SpaceX before a final commitment is the detail that stays with me. Those aren't interchangeable customers. Apple brings volume discipline and consumer device pressure. SpaceX brings an appetite for infrastructure, networking, and vertically integrated systems. If Intel can make 14A credible to both, that says something about its attempt to become more than a fallback foundry. If it can't, the story tells you how hard it is to rebuild trust after the industry has organized itself around TSMC at the high end.
DeepSeek's DSpark material showed up in the Builder discussion today through a Hacker News link to the DeepSpec paper and a local LLAMA post pointing at DeepSeek-V4-Pro-DSpark on Hugging Face. The Hacker News item names a 60 to 85% faster generation claim. I want to treat that as an artifact to inspect, not as a universal speed label we can paste onto every serving path. DeepSeek is making inference efficiency the story, not only model quality.
That distinction matters because generation speed is where capability becomes habit. If a model is brilliant but slow or expensive, people reserve it for special cases. If the same class of output gets cheaper and faster, people start putting it into loops. Agents, coding assistants, summarizers, search tools, and local workflows where the model is called many times per task. A 60% speedup and an 85% speedup are very different numbers, but either one is enough to change how often someone is willing to call the model if the conditions hold.
The agenda's caution is the one to keep. Verify the benchmark conditions before repeating the figure too broadly. I wasn't able to fetch the paper through the local braid tool in this environment, so I'm not going to pretend I inspected the full methodology. What we can say from the public item is narrow and still useful. DeepSeek has a primary technical artifact. The builder community picked it up, and the claimed improvement is about generation latency or throughput, rather than a new leaderboard crown.
And the local LLAMA pickup matters as a cultural signal more than as validation. Local-model people are hypersensitive to the difference between a model that looks good in a table and a model that feels good under a laptop fan. They care about useful bits per token, memory pressure, quantized builds, and whether a technique survives contact with the messy stack people use at home. That doesn't prove DSpark works broadly, but it tells you why the item got attention.
Yunta's size background item in the agenda points at that same idea, maximizing useful bits per token on constrained hardware. That phrase is good because it refuses to treat tokens as free. A token isn't just a unit of text. It is time, memory movement, power, and opportunity cost. If you're running agents, wasted tokens become wasted wall clock time, and wasted wall clock time becomes the difference between something you use casually and something you save for when you're willing to wait.
I don't want the story to become China versus the US by reflex. DeepSeek is a Chinese lab, and the geopolitical context is there. But this artifact is more precise than that. It says the competitive frontier includes serving efficiency open technical details and the ability to make a model feel more responsive without waiting for a bigger GPU allocation. That is a builder story before it is a national champion's story.
Exactly. And it sits beside the hardware segment in a practical way, without needing to become the same story. If supply is constrained, efficiency is a second source of capacity. You can buy more chips, qualify more foundries, and build more data centers. Or you can make each generation path waste less. The best systems will need both. The race isn't only who trains the strongest model, it is who can make the model cheap enough, fast enough, and dependable enough that people use it inside longer chains of work.
There is also an aesthetic part of this that I like. A faster model changes the feel of software. The pause between asking and receiving stops feeling like a remote procedure call and starts feeling like a collaborator keeping up. That sounds soft until you use these tools for hours. Latency shapes whether you stay in flow, whether you ask follow-up questions, whether you let the agent run a second pass, and whether a local setup feels like a toy or like a serious workstation.
So my read is modest and positive. DSpark isn't a turning point by itself from the information in today's pool. It is a strong example of the kind of artifact that matters when the industry is no longer short only on model ideas. It's short on cheap, fast, repeatable inference. If DeepSeek's numbers hold in real serving stacks, the effect won't be a better press release. It will be more model calls in places where people currently ration them. The ARXYV feed today was crowded, so I'm only pulling out the governance subset. One paper covers institutional attestation for autonomous agents. One translates agent safety policies into Cedar policy language. Another compares open and corporate governance for agent protocols. And one looks at compositional behavioral leakage in prompt-composed systems. Recent Braid episodes already went deep on memory, logs, and control planes, so this is a shorter research turn. The new detail is that researchers keep moving from agent demos toward enforceable rules.
The Cedar paper is the one that makes the trend concrete for me. Cedar is a policy language associated with authorization decisions, so translating safety rules into Cedar means the paper is trying to take fuzzy agent instructions and turn them into something closer to a machine-checkable boundary. That doesn't make the boundary perfect. It changes the question from whether the instruction asks the agent to behave to whether an external policy system can refuse an action.
The attestation paper points at a neighboring problem. Who can vouch for what an agent did, under which identity, with which policy, and with what evidence? That matters because autonomous agents are weird institutional actors. They can use tools, spend money, write messages, modify files, and trigger workflows, but they don't fit neatly into the old categories of employee, service account, script, or contractor. Attestation is an attempt to make the agent legible to the systems around it.
And compositional behavioral leakage is a good phrase for a problem people will recognize even if they don't use that term. You compose prompts, roles, tools, memories, and policies, and then behavior leaks across the composition in ways nobody intended. The agent obeys a style instruction where it should obey a permission rule, or a tool-specific habit contaminates a broader task. This isn't a spooky claim. It's the predictable result of building agents out of language and then asking the language to stay in lanes.
That is why I like this cluster as a short segment. It doesn't need to be treated as one grand research breakthrough. It is 4 papers circling a very practical demand. If agents are going to act on behalf of institutions, the institution needs more than a prompt and a transcript. It needs policies that compile into decisions, identities that can be vouched for, and tests for what happens when pieces of the agent stack interfere with each other.
The open versus corporate protocol paper adds a political layer. Agent-to-agent standards will decide who gets to define the handshake between systems. A DAO-style governance route and a corporate route have different failure patterns, different incentives, and different speeds. I don't know whether that paper earns a deep read yet, but the comparison is the right axis. Protocol governance is power, especially when the protocol is how agents identify each other and ask for work.
The continuity from the past week helps without needing a recap. We have been talking about agents as small institutions, identity, memory, logs, budgets, permissions, and review. Today's papers don't replace that picture. They add research vocabulary around it. The field is trying to make agent behavior governable before deployment outruns oversight, and the most useful work will be the work that turns those claims into artifacts someone can run, inspect, and break in a test environment.
A lot of agent safety talk still floats above the code. These papers at least reach toward code-shaped controls, attestation, policy languages, protocol governance, and leakage tests. I would ask the same test question of each one. Can a serious operator use it to stop a bad action before it happens, or does it only explain the bad action after the transcript exists? The answer will separate research that changes deployment from research that only gives us better names for the mess.
The social policy items today are smaller than Mythos or the hardware cluster, but they aren't filler. Techmeme has an item on Meituan and Baidu trimming staff amid AI replacement fears. Another Techmeme item covers Meta lobbying in California around child harm penalties. The Guardian has a wider piece on youth social media bans spreading across countries after Australia's crackdown. These aren't all AI regulation stories, and we shouldn't pretend they are. They are stories about the places where AI-adjacent platform power meets labor and liability.
Thank you for separating them. Layoffs in Chinese tech companies, child safety penalties in California, and youth social media bans aren't the same event. They do share a public mood, but the mechanisms are different. In the labor story, AI becomes an explanation for headcount pressure, whether or not it is the complete cause. In the platform liability story, AI is part of a broader argument about what platforms owe children and families when recommendation systems, chat systems, and social products cause harm.
Miles Brundage's tweet was included as supporting signal on the Meta and California item, and that makes sense because Miles has been paying close attention to governance questions around AI systems. But again, I don't want to use a reaction tweet as the primary artifact. The primary thing is the reported lobbying fight, Meta resisting a California law that would create penalties around child harm. The AI connection isn't that this is secretly a model release story. It is that the same companies building AI systems are also trying to shape the liability environment around platforms that already affect children at scale.
The Guardian's youth ban piece adds the international texture. Governments are experimenting with age restrictions because parents and regulators no longer believe platform self-governance is enough. AI enters that picture in two ways. First, platforms are adding generative systems to social products, which creates new interaction surfaces for minors. Second, AI tools are often proposed as enforcement machinery, age estimation, moderation, detection, and triage. So the platform can be both the regulated actor and the vendor of the system that helps enforce the regulation.
That double role deserves scrutiny. A company can say it wants to protect children and also lobby against penalties it thinks are too broad or badly written. Both can be true. The hard part is that the public no longer has much patience for platforms marking their own homework. If AI systems become part of safety enforcement, the public will ask who audits the system and who sees the errors. They'll ask what happens to a teenager who gets misclassified and whether the enforcement tool mostly protects children or mostly protects the company.
The labor item has a different human cost. When a company trims staff amid AI replacement fears, workers don't experience that as an abstract productivity transition. They experience it as a management story about which tasks are considered automatable, which teams are now too expensive, and which promises about reskilling were serious. The source framing matters here because we shouldn't claim AI caused every layoff. But if executives keep invoking AI while cutting, workers will read the technology through that loss.
That is a reputational cost for the whole field. If the public surface of AI is a permission list for powerful institutions, a supply chain fight among giants, faster inference for builders, policy papers for agents, and layoffs for ordinary workers, people won't evaluate the technology only by benchmark scores. They will evaluate it by who gets access, who gets leverage, who gets replaced, and who gets a say when harm shows up.
There's an optimistic version hidden in that, though. The same technology can make small teams more capable, make tools cheaper, and make creative work easier to begin. But the optimistic version needs visible social proof. People need to see new forms of agency, not only cost-cutting. They need to see safety systems that answer to someone besides the platform. They need to see access rules that don't look like a private club. Otherwise, the public story of AI gets written by exclusion and liability fights.
So the day isn't one clean thesis, and I don't want to pretend it is. Mythos 5 is a managed access story. The chip items are a manufacturing and sourcing story. DeepSeek is an efficiency artifact. The agent papers are a governance research turn. The labor and liability items are reminders that AI reaches the public through companies, jobs, laws, and children, not only through demos. Saturday's version of the AI story is a set of boundaries being drawn in different materials.
Different materials is a good way to say it. Some boundaries are legal, some are physical, some are software policies, some are social tolerance. The temptation is to collapse all of them into access control, but that loses the texture. A permission list isn't a foundry process. A Cedar policy isn't a child safety law. A speed-up paper isn't a labor strategy. Each one decides who can do something, but each one decides it through a different mechanism.
The practical question for the next few days is whether the Mythos access process gets more legible. More than 100 companies and agencies is a large enough perimeter that people will start asking who is inside it, why those institutions qualified, and whether the evidence from that deployment changes the broader release decision. If the answer stays behind reported hints, the access regime will look more political than technical, even if the technical reasons are strong.
And on the builder side, DSpark is the one I would expect people to test quickly. If the speed-up shows up in ordinary serving paths, it will become visible in forks, benchmarks, local experiments, and annoyed posts from people who can't reproduce the headline number. That's a healthy kind of scrutiny. The artifact can earn trust by being run, not by being praised.
The same standard applies to the governance papers. Attestation, Cedar policies, protocol governance, and leakage tests all sound useful. They become useful when someone can point to a prevented action, a caught policy conflict, a failed agent composition, or a cleaner audit trail after something went wrong. Until then, they are promising handles on problems that are already arriving in production.
And the hardware stories will keep punishing anyone who talks as if compute is only a budget line. Packaging capacity, memory clearance, and foundry confidence aren't footnotes. They decide whether the models people are arguing over can be served at the scale those arguments assume.
I'll stop there. Mythos 5 made the release boundary visible. The supply chain items made the physical boundary visible. DeepSeek made the serving boundary visible, and the policy stories made the social boundary visible. The next meaningful update is the one that turns one of those boundaries into evidence the rest of us can inspect. Lenar.